Okay. Hi everyone. Let's look at number 88, merge sorted array. Yeah, we are given a two sorted integer num array, and we have to merge the second array to the first one. We assume that numbers 1 have enough spaces to hold all the numbers. We have done a similar problem, which is merging two sorted linked lists. So in that part, we create a root node, and we just modify the parent-children nodes, and it was pretty straightforward. But for these num array, we cannot just insert, right? Because insert costs time. We have to shift the numbers. How can we do it? But first, we just do the bool force 1, because JavaScript have the splice operation. We can do insert with built-in method. I'll skip it because I have done it, and oh, wait a second, I have done it actually. It's very straightforward. I don't want to write it again. I'll copy the code here. Okay, so we got 2 pointers while P2 isn't finished, and yeah, this is the oh yeah, this I have to write it again, right? Allow me to write it again. Okay, allow me to write it again. We'll just loop through the two array and compare the values. So let P1 equals 0, let P2 equals 0. The condition for the while loop is that P2 is smaller than n. The P2 isn't done. The thing is that if nums1 P1 is smaller than nums2 P2, then we don't need to do anything. We just move P1 to the next one. But if P2 is smaller, we have to insert. So for insert, we use splice function. So nums1 splice. But splice P1, we remove nothing. We just insert nums to P2. But after insertion, there will be an extra array 0, so we have to splice again. Attention that splice cannot be chained. Splice num splice m plus P2. If P2 equals 0, we have splice splice, yeah, plus 1. And P1 plus equals 1, P2 plus because we inserted, so P2 must plus 1. So after P1 all inserted, wait a minute. Okay. While P2 is smaller than n, if P1, there is a problem, is that actually if we continue P1, it will be overflowed. Like this, P1 will go to number 4, but there is actually 3 is the nth. We have to have a condition here. It's like if if P1 is smaller than M plus P1, okay. Is it right? So when we try to insert number 2, we only compare to M. So this is M plus P2. This is right. Okay. So after everything is done, there might be still numbers left. For the other case, no, there won't be. So if not the case, we will say that P1 is overflow. We just set it. We just say nums1 P1 equals nums2 P2. P1 plus 1, P2 plus 1. We return nums1. Run the code. Oh shit. Seems right. Submit. Yeah, this is the previous. This is previous solution I did, and there's a problem that splice is against the rule. I think these algorithms tests. We cannot use splice because each insertion will cause the shift of the rest numbers. Well, in that case, actually, the time complexity will be max m times n. But for the worst case, all these numbers are 1, and all these numbers are 2, and all these numbers are 1. So it will be cause every time shift 1, shift 1, shift 1. So actually, for this second solution, shift insertion is inevitable. So because we assume that numbers 1 have enough space, we can shift it once for all, right? Shift it beforehand, and actually we have another. This is also against the rule, but we can just say we create a const result. This is against rule, of course. Okay, this is result, and while P1 let's create another array. While P1 is smaller than, or P2 is smaller than n. So some of them are there. If P1, if nums P1 okay, let's say n. It's one bit simpler. If nums1 P1 is smaller than nums2 P2, result will push nums1 P1, and then P1 plus equals 1. For the other case, result push nums2 P2 plus 1. And now at the end, if P1 is still there, we will push them. So result, I say new array m plus n, result No, let p equals 0. We don't use push, we just say p result p equals nums1 p1. This should be the same for p2, p plus 1. If p1 is still there, so for p1 smaller than m, p1 plus p, oh sorry, p1 plus, then result p result p equals nums1 p1 p plus. We'll continue while p1 smaller m. There's no if check. While p okay, p nums p1 plus 1 p plus 1. This is the same for p2, but these were not conflicting. We have checked here. So p nums 2, p2, p2, and finally we return result. This is the solution that we have a third array. Run answer. Oh yeah. While p1's p2 nums p1 smaller and p equals p1 plus 1. Okay. Else p2 equals p2. Okay, p2 plus 1. This is right. And then if p1 plus p1 plus 1, result p equals nums1 p1, numbers 2 p2, while p2 ppap. Oh, ppap return result. I think it is. There's nothing wrong. There's nothing wrong. One, two, three. Wait a second. If p nums, we compare 3 to 2, but it's bigger, so we resolve p equals nums 2p, p2 plus 1. Console log p1, p2. What happened? Uh, 1, 0, 1, 2. So yeah, right. Per numbers 2p, p plus 1. Output. While p1 is smaller than m. What's the problem? Console log result p1, p2, p. PPAP, 2 empty items. 2 empty items. So this should be n. My bad. PAP, n. Result p equals nums 2, p2. I cannot find anything wrong here. Maybe something wrong is here. P2 is 1 smaller than n. And m and 3. So result P. Result 4 is equal to nums 2. P2. P2 is 1. So 4 should be 1. I'm not sure what is going on. Console. Sorry. The function said that do not return anything. Modify nums in place. Yeah, actually this one should be working, but we have to do it inline. So what's this case? Actually, we see that we can actually we have an extra n space in nums1, so we just move this n space 1 at the beginning, and we can do that the same, right? So the first one is shift the numbers of nums1 to the n. For let I equals uh, 0, I smaller than m, I plus plus. So there should be nums1 nums I plus n equals nums1 I. So now we have this space. So let p1 equals n. Let p2 equals 0. So while p2 is we can still say 0. While p1 is smaller than m, and while p2 is smaller than m nums p1, but here it is problem, p1 plus n. Result p equals now equals p1 plus n with plus 1. Okay, so then now plus 1 p plus n, and while p2 okay plus, so we return nums1. And now the result is gone, so let p equals 0. So we should be nums and nums1. Okay, we run the code. Yeah, it's working. Wrong answer. What? Wait a second. Nums1. We move them, right? P1, 0, 0, Pm. So the start should be nums1 P. Yeah, nums1 P1 plus n. Yeah, nums1 P. Nums2 P2. Yeah, P1 plus, yeah. And nums1 P plus n. And what's return nums1? What is the problem? This is strange. Console log nums1. This is the case. I equals 0, I smaller than m, and plus us, I equals I n. I made a mistake. This should be. I made a huge mistake. I cannot do it from the beginning, but backwards. Yeah, if I do this, there will be this one be 1, and this will be also 1, 1, 1, 1, 1. So we should be backward. Do it backwards. Yeah. My God. Because there will be overlapping. So. So nums should be we do it backwards. Anyway, we should say it should be m, and we should be minus bigger than 0, I minus, so it should be m plus m minus 1 equals nums I. Yeah. Okay, still wrong. What? Nums m plus n. Not m. God. I plus n. If that's the case, I should do it like this. Okay. Yay! We are accepted, but it's slow. Maybe because of this console. It's still very slow. Let's say if we can improve it. Wow, this one is fast. Pointer printer, new array splice. Wow, this one is against the rule. It copied new array. It's a cheat. It's cheating. Like this one. Wow, this is fast. Items to place plus. Ooh, what is this? Wow, wow. What is this guy doing? Items to place. M minus minus. N minus minus. Just place items back there. So if there is an n is bigger than 0, there's still n, and there's space to put. Then if the first array is bigger, then we say nums1 items to place nums1 m minus nums1 place numbers 2 minus. So he's suggesting that we should do it in the different order. We compare not from the beginning but from the end. If this is the largest, then shit! Wow, this is very super cool. Yeah. We don't need to shift. We just we can do it backwards. Like we're currently shifting these numbers and get the minimum, but we can actually do it backwards and moving the largest here. Wow, this one is genius. Okay, let's try again. So we don't need to shift. Okay, so the pointer here, it should be let point 1 equals m minus 1. Let point 2 equals n minus 1. Wow, p1. So when should we end? Wow. Oh yeah, this is cool. While p is bigger than 0 and p1 is bigger than 0. If there is a case that no, there's no case that both of them could be 0. One of them is 0, then let's say I got this one to 0. If I got this one to 0, then let's say there's only one number and we got 1, 6, and then it should be there. What if 1, 1? Then it should be there. So there's always one space ahead of them. Right? Yeah. So they will end like this, bigger than 0. Yeah. Okay. So now we will compare them. If nums1 p1 is smaller than nums p2, so p2 is the largest, so we will say nums p1 plus p2. This is n minus 1, this is n minus 1. So the plus, this should be m, index should be plus, it should be plus 1, yeah. The number should be, yeah, plus p2 plus 1. Should be nums2 p2, else p2 minus equals 1. On the other hand, it should be p1 numbers 1, p minus 1, p2 p minus 1. So after this is done, return nums1. This is right. So we move this one to the largest and then go to 5 and then compare it again until some of them are going to 0. like there's a case that like for 10, 0, 0, 0, 0, and we have 2, 5, 6. And now with our algorithms, well, this will become 10, and then we will compare. So some of them will be left it. If num's 1, then it is okay. But if it's number 2, oh yeah. So if P2 is bigger than 0, P2 minus equals 1, but we have to say numbers 2P here should be numbers P2. Which is to set move it back, move it to number 1. If that's the case, I think P1. Yeah, that's it. It might be right. Oh, it is wrong. God. Five, 4, 6. We got 4. Something is wrong. Okay, we got this right, but nums 1, nums. P2 is, we got 4, 5, 6 right, and P2 is bigger than 0, so we say nums 1, P2 equals nums 2, P2 equals minus 1. We got 5, 4, 3. There's no 5, 4, 3. Maybe we got 3, 4, 5, but here for 1, 2, we got 4, 4, 5. Something is wrong. Ah, God. God, my God. This should be a while. So, oh, there should be also a while P2. Oh, yeah, if not, it's not if. Oh, yay! We're accepted. Wow, I love this guy. This God. This help. Wow, this guy is very fast. This guy is very fast. So the while is say he said the ending condition is item to place. Aha. So the M should be wow, this guy write very condensed code. There's still M, and there's still items to be placed, M plot, and if nums 1, oh, here's some undefined, right? There's P plus 0, and the ending condition should be P1 plus P2 should be bigger than 0. Oh no. I can understand. But this is very straightforward, right? So if both of them they're there, one of them is left out, so we just assign them. This one, numbers P2 equals numbers P2. It's likely to be this. So P1 must be minus 1. Minus 1, so with this will be the same, actually. If nums1 is smaller than this one, so actually there's no need to be put here. But if P is ended, oh, maybe we don't need this one. Cool. Maybe, but I'm not sure. Call an what? Hit out of memory. So for this case, the P2 would always not be on 0. So, oh shit. So the P1 plus P2 should be better than 0. Right? If we got 0 and 1, P1 is 0, P2 is 0, that is 0, 0, okay. So numbers 1 is 0. Oh, number 1 is 0. So it's minus 1. Minus 1 plus 1 is minus 1. So minus 0. No. 0, 1. So we should minus 1 and 0. Minus 1. And P2 is 0. And P1 is smaller. So it should be nums1. It should be changing to this condition if it is bigger than it. Else we set it to numbers 2 because we're merging numbers 2 to number 1. So this should be that bigger than 0. Both of them, so we set minus 2, right? It doesn't change that much. Personally, I think the previous solutions will be better, will be more understandable for me. I like this. I like to make it clear. This guy wrote some code. It's hard for me to read. Okay, so that's all for this question. Thanks for listening. Hope to see you next time.